Hello guys, today we are gonna talk about how to model the mass spring damper system in system modeling perspective and how to be used in the simulation program such as the Matlab Simulink or the Python or the C++ programming language. Okay, so this is the first lesson of the Phinite Academy, and then we will evaluate or discuss about how to use the mass spring damper system in this notation and how to be cover of the full underlying mechanism of this perspective, especially in the dynamic form of the universe response. Okay, and so firstly we should give some head in here, and so mass spring and damper system modeling, which is given in here, and then we should give the specific subhead for in order to understand this modeling mechanism in here. So in our lesson, in the first place, we will focus on the analogy modeling perspective, which means that we utilize this thing in, especially in the system modeling, is a useful tool to analyze or write a specific notation for the mechanical or electrical or hydraulical system in system dynamics perspective. Okay, and so in order to cover this notation, we should get some specific constant or the effective parameter in the universe or the physics, which we call the mechanical or the universal parameters notation. It is the notation. It is the second subject of this lesson, which means that it's called by the M mass, damping ratio and spring coefficient of the system modeling perspective. Okay, and so in order to link these two things with between the mechanical parameters MCK and the analogy modeling, we should utilize the energy forms like preserve the energy, which we called in the next lesson M mass, and so we have a storage elements in here which we call the K spring coefficient, and we have the loss energy form which identified by the damping ratio in this lesson. So in order to create a some specific rule or notation, we should energy forms to combine these two things in the dynamics perspective of the system modeling approach. Okay, and so we should pass to the shape parameter selection subject, which we can drive the full model of the MCK parameter with the usage of the shape notation in 3 dimension. Okay, and so for example, M is the density times the volume, and volume is a shape, and so we can drive the mass parameter based on the shape parameter selection or in physics notation. Okay, and so after that we can pass to create the specific notation of the dynamical equation or equation of motion is obtained in this lesson related to the mass spring damper system. Mass spring damper system is a useful system because anything in the universe can be modeled by using these things, okay? And so, in order to cover these things or get the full information about these things, which we call the theoretical information, and then we pass the system simulation toolbox, or which we call the programming language Matlab, which is used in this lesson with the toolbox of the simulating diagram and script notation, especially in the command window. And so we get these tools to create a dynamical equation of motion in mathematical form in the usage of the Matlab programming language, okay? And so we created a Matlab program to imitate whole the dynamic equation of motion related to the mass spring damper system modeling at the end of this lesson. In order to do that, we can create a transfer function model in here, state space model in here, and with respect to the script notation or the implementation of this mass spring damper system, we should also use the transfer function and state space model in this notation, especially by using the Matlab code or the Matlab function notation, which we can write a specific code like the C programming language or the Matlab programming language, and then we get the full picture of the dynamical equation of motion of the mass spring damper system modeling. This is an introduction of our lesson, and we should proceed with the analogy modeling perspective in the next lesson.